Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we will discuss question number 27 of NEET Physics paper 2016. Student, let us start question number 27. The question is two non-mixing liquids of densities rho and n times rho, where n is greater than 1. That means out of these two non-mixing liquids, this one is having lower density and this one is having higher densities, n times rho. N is greater than 1, so this is higher and its density is lower, are put in container. In a container, the height of each liquid is h. A solid cylinder of length L, so basically this is a container in which these two liquids are put, and up to the same height. This is another liquid. Its density is rho and its density is n times rho. The liquid having low density will lie below this lighter density. Now a solid cylinder of length L and density D is put in this container. A solid cylinder has to be put here. The cylinder floats with its vertical axis and length rho L in the denser medium. So the solid cylinder is put inside this liquid and it floats with its axis vertical. This is the vertical axis, and the part of the solid which is in the denser medium, that means in this liquid, is rho L. This length is rho L, because this length in the denser liquid, and the remaining portion, total length is L, so L minus rho L. This part of the length will be lying in the liquid of this density rho. So this length is L common 1 minus rho. So this part is in this liquid, and the density of this cylinder is D. So this density is D. This is the density of the solid cylinder which is floating in the mixing of two liquids. Now you have to find the density D. That you have to find how much is the density of this solid cylinder. Now we know that if this is floating, it is in equilibrium. Floating implies it is in equilibrium. That means the net force will be 0. The downward force and the net upward force will be 0. The net downward force is equal to net upward force. Now, what are the forces acting downward? It is only the weight of this solid cylinder. So we'll write that the weight of solid cylinder is equal to, what are the forces acting in the upward direction? It is due to the buoyancy due to this liquid and buoyancy due to this liquid. These are the two forces, buoyancy forces, FB say 1 and FB 2. So buoyancy force due to first liquid and buoyancy force due to second liquid. This implies that the weight of the solid cylinder. So this is the cylinder. Its weight will be mass into G. And what is the mass? Mass is density, that is the D, density of the cylinder, and volume. Suppose that the area of cross section of the cylinder is A. So it's A into the total length, that is L, and G is there. So this is the weight of the solid cylinder. So I'll write that DALG from here, which is equal to the buoyancy force due to two liquids. Now the buoyancy force is what? What is buoyancy force? Buoyancy force is the weight of the displaced liquid. The weight of the displaced liquid. That is, if I think of the first liquid, which is having less density than this one, red one, how much portion of this material is inside this liquid having density rho? We can see that the volume of this solid which is in this liquid is the area cross section of this cylinder and this length, that is this length, because this length is inside this liquid, so that much of volume has to be displaced. So weight of that displaced liquid is this volume, and this density will be the mass of the liquid displaced into G. So therefore for first one, the area into length is L into 1 minus rho, that is the volume of the displaced liquid, and density of that liquid is rho. Density of that liquid is rho, and this is the volume and this is the density, multiply this mass into G. This is the weight of the displaced liquid due to the first liquid, and similarly for the second liquid, the area of cross section, the length of that part of the cylinder, which is rho L. So area into length, this is the volume, this is the volume, and what is the density? Density is N times rho. So N times rho, so this becomes the, so this is density, this is the volume, so this becomes the mass, and into G. Okay, so now this is the equation, and from this equation you have to find the value of D. We are interested in finding the value of D. So you have to make D as a subject, so you have to separate that. So from here I'll just simplify this and keep D here, and ALG I will cancel out from both sides of the equation. If I cancel ALG is there, ALG is here, so that I'll cancel ALG from here, ALG from here, ALG from here. If I cancel, then I'm left with D equals to, this is rho into 1 minus rho plus N rho square. Now I have to see the option. This is actually PL. This is actually PL. This is not rho. This is actually P. Okay. So this is not rho. This is P. Okay. So this is P. So wherever the length, it is P. It is the P. And this is the P. Not rho. This is actually P here. It looks like rho. It's a P here. So this is P here, and this is P. This is P into rho. This is not there. So let me write that again. D equals to rho into 1 minus P plus N rho P. Okay. Now, if you see the options, then you see that rho is common in all the options. Okay, this is the square bracket, this is the bracket, this is the bracket, this is the bracket, and rho is out. So first I will take rho out and see which of the options is matching. If I take this rho out from here, then row I will take out. See what I am getting. 1 minus p, this is there, plus n times row. So n times p. N times p is there. This is row is out, so p is there. Now what is left is 1 minus p plus n times p. So I'll just reopen that. 1 minus p plus n times p, and this is the row. From here I can write 1 plus I'll write p common, n minus 1. Okay, so it is 1 is there. From p, if I from these two terms, if I take common p, it will be n minus 1. So plus n minus 1 into p. This one I'm getting. So this is the value of d. If I see the option, this is bracket 1 plus n minus 1, 1 plus n minus 1 into p, n minus 1 into p, bracket closed, density of the liquid. So just let me just tell you one more thing, that this is basically the length which is written as rho L. This is PL, so this must be P. This is actually P. This is actually P. Okay, everything is rho. This is density rho. This is density n times rho, and this is PL. This is 1 minus P. So P is coming out. So here this is P. This is P. This is P here. P here. P here. Okay. So that is the answer, and the answer is option number 1. Option 1 is the correct answer to this question. Okay, this is a very simple question. Thank you.